Hello and welcome to the Marine Biological Association's podcast, The Marine Biologist. This podcast is the accompaniment to our magazine, also called The Marine Biologist, and it explores the current issues that face our ocean. If you'd like to find out more about the Marine Biological Association or where you can get your hands on the Marine Biologist magazine, then please visit our website, www.mba.ac.uk. Enjoy the episode.
Welcome to the Marine Biologist podcast. My name's Guy Baker and I'm the editor of the Marine Biologist magazine.
And I'm Lizzie, the Training and Events Coordinator for the Marine Biological Association.
Today we'll be discussing exploration versus exploitation in the deep sea, following on from an article that appeared in the October edition of the Marine Biologist magazine. We're delighted to be joined by the author of the article, Amelia Bridges, who is a deep sea ecologist who specialises in spatial ecology in the deep sea and how science can help policymakers decide what we can and can't do in the deep sea and which areas are particularly special. So thank you very much, Amelia. Welcome. And my first question for you is, what got you into marine biology and how did you end up in deep sea research?
Hello, it's lovely to be here. Thank you for having me. I'm going to give the ultimate cliched answer, which was I've always loved the ocean, to a point. So I grew up in Cornwall, so just down the coast from Plymouth, and I grew up rock pooling and being really inspired by the local marine environment, I suppose. So even when I was kind of like 5 or 6, I was like, I want to be a marine biologist, even though I don't think I knew what that meant. So from there, I kind of went through the traditional GCSEs, A-levels, and then started looking at undergraduate courses in marine biology. And I ended up coming to Plymouth. And I never looked back really at that point. So I, for my undergraduate dissertation project, I went to my tutor, who is, Dr. Kerry Howell at the time, but now Professor Kerry Howell. And I said, I'm really passionate about conservation. I wasn't like overly drawn to any one habitat or ecosystem in particular. It wasn't like I loved seagrass or I really loved dolphins or anything like that. I was just passionate about conservation. So I said that, and I was like, have you got any projects that I can get involved with and write for my undergraduate, given she heads up the deep sea conservation research unit. So very kind of like focused on that. So I did my undergraduate dissertation looking at sponge aggregations in the North Atlantic, and their kind of like footprint with potential fishing activity, and how that ties in a policy perspective. And that got me hooked, really. So that led into my PhD, which was then similar kind of like ecological study, but to inform management. And that was at the South Atlantic, which has led on to several different postdocs, but all kind of focused on that deep sea and conservation aspect.
Cool. So you've mentioned you started with this passion for conservation. How would you say that your work contributes to specifically deep sea conservation?
That's a very good question. So I think throughout my relatively short career, I mean, I only finished my PhD a couple of years ago. I think myself and then others in my team, led by Kerry, we kind of adopt a number of different approaches to kind of informing conservation and sustainable management. And they range from really like fundamental contributions, like assessing biodiversity, doing species inventories, basically what's there, right through to kind of like very targeted work that looks at taking a scientific body of work or a scientific output. It might be like a predictive model, and then using that to inform policy. And what does that kind of like pipeline look like? So I guess in my PhD, like a kind of me specific example would be in my PhD, I focused on deep water ecosystems in the UK overseas territories of the South Atlantic. So mainly Ascension, St Helena, and Tristan da Cunha, which, if you don't know, they're kind of like slap bang in the middle of the ocean between West Africa and South America. And they're really amazing ecosystems, but no one, given they're so remote, that the kind of, I guess, our knowledge of them is incredibly limited. And then if you put the caveat on that of deep water knowledge, it's even more limited. So a lot of my PhD was looking at kind of developing those first inventories for places like Tristan da Cunha. But then by the end of my PhD, I was working alongside a team from like RFPB, CFAS. We were involved in the discussions of what the marine protection zone that they brought in a few years ago looked like. So you have, the bird people saying this is really important spot for birds. And we were able to, through that work that we'd kind of been doing over the 3 years prior to that, we were able to say, well, actually, our models suggest that this area of seabed is really diverse, or this is particularly important for this type of species. So we were looking at cold water coral reefs, which are really important ecosystems. So they provide habitat for lots of other species like fish, and then loads of invertebrate species as well. So through our mapping work, that then fed into that kind of policy. We were like on the front line in the meeting rooms, drawing lines on maps and going, this is particularly important, this is also important, perhaps in a different way. And it was kind of a really interesting experience to be sat in a room with lots of different people, and we all kind of have one similar priority in the sense of we need to develop a management plan, and we need to bring all of our science in and contribute towards conservation. But obviously, I'm a benthic ecologist, not a seabird ecologist, and as you know, Claire across the table was a seabird ecologist. They like trying to balance everyone's priorities was quite interesting. But so it's nice that I can definitely look back, particularly at my work in my PhD, and it at least to me is clear that we kind of have that pipeline from very fundamental assessments through to drawing lines on maps and putting marine protected areas in place.
What are the obstacles to putting in place marine protected areas in the deep sea?
Where do I start? So there are a number of obstacles, but hopefully they will be far less relevant than they are now, I think, in 10 years' time or at the end of the UN decade. I think the top two probably biggest obstacles that are kind of joint first place at the moment are firstly a lack of governance framework. So at the moment there is no framework from which to designate holistic marine protected areas. You can designate areas that are protected perhaps from one industry. So for example, regional fisheries management organisations can designate an area that will be closed to demersal fishing, or the International Seabed Authority can designate what they call areas of particular environmental interest, or APEIs, within which they won't license any mining, exploration or exploitation. So you've got these kind of like sectoral designations, but at the moment there's no way to designate an MPA that protects from all anthropogenic activity or all extractive activity. However, the good news is the High Seas Treaty. So it's been in a draft phase for decades. And earlier this year, the text was agreed at the UN, and now they're in the process of getting that treaty ratified. And within that treaty, there is actually the legal framework that we could start to designate marine protected areas in the high seas from. So that's really exciting. But if I had my pessimist hat on, that's all well and good, but we also are extremely data limited for the deep sea. So I think alongside kind of pushing that legislative progress and making sure things like the High Seas Treaty are ratified, it's also really important to not take our eye off the ball and make sure we are still continuing to go and explore new areas, collect more data, collect the right type of data, so data that's comparable and is stratified across really essential ocean variables, and they're actually called that EOVs, data that's stratified across EOVs so that we can answer some of the fundamental questions that we're missing the answers from in terms of deep sea, like where do species live, how many are there, what identity do they have, how are habitats connected, especially across such vast distances. So that lack of data, even if we could designate MPAs immediately, I think that lack of data would still be quite a hindrance. So those would be my two kind of big ones, I guess. But you also have, of course, the high seas, so area beyond national jurisdiction, is what's called a global commons. So it's a common heritage of mankind. You guys both have as much right to be there, in inverted commas, as Shell, as the director of the BBC, or or just your average Joe Blogs off the street. Like we are all stakeholders in that commons. So managing that and managing those expectations of society and humankind, I think, is going to be particularly challenging. And then enforcement challenges, it's such a massive area. How on earth do we start? You could put an MPA in, but to ensure it's not one of those paper parks, we need some level of making sure that they are adhered to. So if you're banning fishing in an area or banning mining, making sure that those activities aren't taking place. And I think that's going to take an extraordinary amount of global coordination across sectors, private sector, government, NGOs and charities. I think we've got a long road ahead, but I'm hopeful that is going to be a positive road overall. I think there'll be hiccups, but there are always hiccups, road bumps.
So when you talk about getting people involved, especially the general public, why should people care about what happens in the deep sea specifically?
It's a great question, and I think sometimes we struggle with it because it's so far away. So to actually access kind of deep sea, it's not like in the UK we have such a shallow continental slope and a continental shelf, that it takes a long time for us to actually even reach deep sea as deep sea scientists. But that's not the case everywhere. So in a lot of small island nations, actually you can be over 1,000 meters of water and still be in sight of land. Okay, and I should say that the deep sea is traditionally viewed as 200 meters and below. So any water column and seabed below 200 meters is deep sea. And of course, if you look at the average, I guess the depth of the shelf and things like that, it's much shallower than that around us. So it is very much out of sight, out of mind. I think there is, of course, a huge intrinsic value of the deep sea. So, away from economics and social values, just the amount of species that live there, the vast areas it covers, the unique types of habitats. I mean, hydrothermal vents, they're like little underwater volcanoes. It's crazy. Like the extreme environments that you find, they're intrinsically valuable. But as much as some people do get that and do understand that, I think for a lot of people, it's important to bring in the ecosystem services that the deep sea provides as well. So ecosystem services are basically the direct and indirect contributions that natural ecosystems or habitats provide to humankind. And it's a train of thought that is increasingly being used, particularly in policy, to start valuing natural capital, so those ecosystems and habitats. And so some people at the University of Plymouth here are doing some pioneering work trying to describe what do ecosystem services look like in the deep sea? Do we know enough about the deep sea to start thinking about what services it provides? But some of the kind of key ones that are coming through really is it's got an incredibly critical role in regulating climate. So the Earth's climate, the deep sea stores huge amounts of carbon in a relatively stable environment at the moment. So we, of course, given we're staring down the barrel of climate change and the climate crisis, we don't want to do anything to upset that balance. From a socioeconomic perspective, it obviously underpins fisheries. That's not only vast commercial fisheries, but also even particularly in these nations where they have deep sea very close to their shores, even that kind of fishing that is being done from traditional local boats and things like that. And then bioprospecting and pharmaceuticals. So is the cure to cancer in the deep sea? I don't know, but it would be a shame if we disturbed it all to the point where we never found out. So yeah, I think there's lots of reasons why people should care. It's just finding a way to verbalize that. but it's so difficult because it's so far away.
And for people listening today, as well as the general public, how can they have their voice heard when it comes to deep sea, especially in terms of exploring it rather than exploiting it?
So that's a really good question. I think you can make your voice heard through various different channels. Okay, so ultimately it comes down for advocating for responsible, sustainable and equitable management and activity. And I think you can do that firstly, even if, I don't know, you're on Facebook and you see an interesting fact about the deep sea, or I don't know, a clip from Planet Earth 3 or Blue Planet, and you think, oh, it's actually really cool, like share it. Share it, because the likelihood is that someone on your friends list will think it's cool and they might know less about it than you. So just that basic sharing information to raise awareness. I suppose down the slightly more active role, there are lots of consultations that do take place. A lot of them do perhaps require, specialist scientific knowledge, but a lot don't. A lot of them might be people trying to gauge what the general public think of the deep sea, or how do they value it. And we're seeing all these kind of like willingness to pay studies and things like, how much would you pay for a healthy deep sea, or how much would you pay for a coral reef, kind of thing. So I think participating in that research is really important. Petitions as well, I know we kind of, I guess, a little bit desensitized to petitions sometimes when you see like 1 billion going around, but you quite often see them. I mean, deep seabed mining is a particularly controversial activity, and you often see big NGOs getting involved in sending out petitions, doing a bit of lobbying, raising awareness. So signing those petitions, if there's something that you vehemently disagree with, I think is really important. And ultimately, I mean, in the UK, contacting your MP and just saying, kind of putting your hand up and just saying, I care. I think it's all too easy for people to assume that almost like no news is good news in a way, like, oh, well, no one's contacted me, and it might sound really odd, but no one's contacted me about deep sea mining, so maybe I'll back that bill. Or, whereas if they do have a letter, it might be a bit left field, it might not be about potholes or something. They are likely to remember that, and then, and consider whether it's really something they want to support. But I think that a mixture of bottom up sharing information and also top down giving, kind of, feeding information to your MPs is really important.
And I take the point, it's hard to engage people with the deep seabed because it's so remote. But there's life in that huge volume of deep sea between the seabed and the surface waters. So how do we get people to understand about that and think of that as important as well?
Incredibly difficult. So I guess in the water quality, I mean, yeah, I'm coming at this from a benthic ecologist viewpoint, but of course, actually, if you think about the deep sea and what makes up the volume of habitat, you're right, it's not the seabed at all, it's actually that middle bit. And I think there's a lot of work going on to understand what is happening and the importance that quote unquote middle bit plays. So, in the article we speak about mesopelagic fisheries, for example, which are potentially being eyed up as this new exciting resource for fish meal and pharmaceuticals. But actually, do we know enough to say, okay, well, if you took out a large biomass from this trophic level across this vast area, what would happen? What would the knock-on impacts be? So I think it's incredibly, if anything, perhaps we know less about that middle bit than the seabed, but just because there's so much of it. And I think every dive that you can see, there are certain companies, particular organizations, I suppose, in the US that live stream video from ROV deployments. So robots that they send down to the bottom of the ocean, they live stream those. And actually, although I'm very much biased towards the seabed, sometimes you'll put it on and they've not quite reached it, and actually you see like so much in the water column go past the lights, and it's a mixture of marine snow, so that food that is so limited in that environment, so it's so valuable, but suddenly you'll get like a huge copepod swim past, or a cephalopod, or there'll just be a shark come and check it out. We were off the coast of Ireland in the summer, and it can be quite a when you're waiting for the ROV to hit the bottom, say you're going to 2,000 meters, it takes a little while, so you're kind of sat there and you're chatting with the ROV pilots, and someone sounds very excited and shrieks or something, and they're like, I'm sure that was a shark, and you go and check all the other cameras and you're like, oh my god, it was, it's like a huge shark or something, and it's amazing that you can drop something which is effectively smaller than a pinprick, right, smaller than a needle in a haystack, and be so close to a shark, or to have seen that cephalopod or something like that. So yeah, you're right. I mean, it's incredibly exciting. That middle bit is incredibly exciting part too.
And for any particular feature on the deep sea bed, like a seamount or a hydrothermal vent, can you tell where in the world that is, or are they essentially the same wherever they appear around the world on the deep sea bed?
Yes and no. So a seamount is a seamount a lot of the time. So what you would typically find is that topography plays an incredibly important role in driving the distribution of communities and species. So, for example, if you are looking at the steep slope of a seamount off of New Zealand compared to a steep slope of a seamount off of the UK, you wouldn't be surprised to see the same types of community. You might see, if it's steeply sloping, that might mean that it's kind of, wiped by very fast currents, which mean it's hard substrate. There might be lots of filter feeding communities that live there, and you might see the same type of community, but of course species identity are likely to be quite different. You do get some species that have what they call a ubiquitous distribution. So Lophelia pertusa, or now Desmophyllum pertusum, which is a reef-forming cold water coral reef, is found in almost every ocean basin in the world. And it's the same species, but a lot of the time the kind of epifaunal communities that live on that reef structure are region specific. So there's high levels of endemism in these environments, and that's because they're so isolated. But in terms of, it's not like you have, sea cucumbers on one and coral reef on another. It's not that different kind of thing. But obviously you do get species that are endemic to one particular area, and they're always very exciting to see.
And talking about different species and habitats within the deep sea, do you have a particular favourite deep sea creature?
I'm trying not to be basic and choose coral, but my PhD was largely on coral reef, so it does hold a special place in my heart, particularly Lophelia. I used to refer to it as the poster child of deep sea conservation, because you do find it everywhere. It's a coral reef, it looks like a coral reef, and you say coral reef, most people obviously think of the Great Barrier Reef or tropical shallow water coral reefs in the Red Sea or something that they've maybe seen on holiday. So it gets such a good kind of response when you go, actually, this is in the deep sea, and people are like, what? But if I wasn't allowed to choose Lophelia, I'd probably choose crinoids in general. So sea lilies, I just think they're beautiful. And the benefit is you often see them on reef. So I think there's actually a picture in the article that we sent in that was from the same cruise off of Ireland this summer. And you've got, these beautiful glass sponges that look like vases, but you've also got some Lophelia in the background and some crinoids. So that's why I like that shot so much.
Very, very naive question, but how can you get some things which are spread around the world, like Lophelia, and other things which I've heard are very, very localized, a whole species might only have a distribution of the size of a few tennis courts?
Yeah, so it's largely going to be, it's about connectivity and dispersal. So typically, the deeper that we go in the deep ocean, the slower currents get and things. So if you look at currents that perhaps wash the side of a seamount, they might be hugely fast, speedy, agile, energetic currents in comparison to those that perhaps kind of like wander across the abyssal plain or something. So of course, if you've got I don't know, a sea cucumber, say, on the abyssal sea floor that releases eggs or gametes, or just is a broadcast spawner in general, if you do have that, then, and it has incredibly slow currents, that larvae doesn't have an opportunity to move quite so much. Whereas things that live in perhaps more energy-rich environments, when I say energy, I mean kinetic energy, then are much more likely to kind of move around. But we also see with dispersal and connectivity, there's kind of this idea of stepping stones. So this is particularly true for seamounts. If you imagine that, if you took a map of the, I don't know, Pacific, and you said average seafloor depth is, let's say, 5,000 meters, and you've got a coral that lives at, I don't know, let's say 1,000. So it's found on seamounts and ridges and those kind of like topographically complex features that you might find dotted about. Obviously, a lot of the habitat surrounding those seamounts is not going to be suitable for the coral. So it might spawn and it might lose a lot of the larvae, and that's why they produce so many. Is because they lose so many as well. So they have very high fecundity sometimes. But you might kind of release loads of larvae, and then, I don't know, a handful of them, it's not going to be exactly a handful, but will reach another seamount, okay, but the rest will kind of be lost and won't ever hit suitable habitat. But then if enough of them do that, you start to kind of have self-recruitment within seamount 2, if you like. So you've got a coral reef formed on seamount 1 and seamount 2. And say your prevailing current is east to west or something, and then you've got more seamounts to the west, you'll keep getting that kind of like handful of larvae that get through. And eventually, and that's why it's stepping stones, you might see dispersal across whole ocean basins, and you're like, how on earth did that get there? But actually, if you kind of blank out all the areas of the map and just look at where it could be, it can sometimes be like a lovely kind of direction map of where it might have been. And obviously there are, genetic ways to validate that as well. But yeah, dispersal modelling is definitely something that's very interesting and can shed a lot of light on connectivity, which is really important for conservation as well.
And Amelia, what has been your most exciting deep sea moment?
I thought about this for a long time. So I think, and this is a bit of a geeky favourite moment, actually. I'm not sure how many people will will be able to empathise with this. But I mentioned earlier on that in my PhD, we had I guess the big paper, the big bit from it, was looking at habitat suitability models. And whether we can transfer them to new areas to start filling data gaps. So obviously I've said that particularly the global south is very data deficient. And can we use some of our knowledge from the northern hemisphere, and I don't mean institutes of the northern hemisphere, I mean what we know about ecosystems in that hemisphere. Can we use that to train models and algorithms that we can then use to predict in like these never before seen areas? So that for me was one of the most exciting questions in my PhD, and we genuinely we thought it should work. We were like, we're 99% sure, well, maybe not quite, but we think this should work. Ecologically, it should work. The theory was sound behind it, but no one had ever really done it for deep sea ecosystems before. And we had an expedition going out to the South Atlantic, so to the sites where we had transferred our model to. And I wasn't able to go, but luckily they had good enough WhatsApp on the ship, which is very unusual as well. It was like the stars aligned. And I remember being, I'd actually gone home to visit my parents. So I was in like my childhood bedroom, on WhatsApp, speaking to scientists on the ship, and they're being like, the drop camera's going down now. This is a really high reef prediction, and then getting a picture of everyone like cheering next to a screen, like your model was right. That was pretty epic, although quite geeky. So I'm not sure. I think that has to be my favourite moment so far.
No, I can appreciate that. It sounds great. And what advice would you give to someone who's considering marine biology as a career?
when I wanted to do marine biology and I was choosing like GCSEs and A levels, I was always asked, was I sure? Because of the quote unquote poor employment prospects in marine biology. I was always asked, like, are you sure you want to do marine biology? Why don't you just go to, you're clever, why don't you just go to a Russell Group university and do biology, and then you could specialise at postgraduate level? And I'm so glad I didn't do that. I think if you're really passionate about something, you will make it work. So obviously I did my undergraduate with, I think there were about 30 people on my course back then. It was a while ago. And of those 30 people, I would actually say a reasonably large majority are now working in the marine sector, whether that be, I've got friends who are MPA policy advisors at DEFRA. I've got friends that work for like climate charities doing marketing. I've got other friends who went down the academia route. So I think don't let that sway you. I think if you're really passionate, you will make it work. And it won't be a linear journey. There's no such thing as I did my GCSEs and then my A levels and then my bachelor's and then my master's. Something always goes wrong. Like, expect something to go wrong at some point. But I think if you're really passionate about it, you'll be able to put that train back on the tracks, as it were. I think, although you don't have to be a maths whiz, being able to code or understanding how code is put together is quite important in this day and age. Like, of course, you can do an analysis of variance by hand or an ANOVA, and it's important that you know how to. It's important that you know what these statistical tests are asking and what they're proving or disproving. But honestly, who has time to do it by hand every time? Like, being able to automate things, even if it's data manipulation or file management. The videos that we collect from ROVs are like terabytes and terabytes and terabytes, and data sets are enormous. Like, so being able to manage those does require some kind of coding experience. And then just that it takes all sorts. You need good, knowledgeable people in academia as much as you need them in NGOs and charities, as much as you need them in the private sector and in government, and in companies that you might consider, on the other side. But actually, it's really important, in order to be able to make good connections and have good conversations, you need people that understand where you're coming from. So I think that's really important, knowing that it's not, just you do your undergrad and then if you're smart, your master's and your PhD, and then you crack on down that academic route. There's so many different routes to go. And you do need, as I say, those good, knowledgeable people across the board. Greenpeace need them as much as universities need them, as much as Shell needs them. So it's really important. It does take all sorts.
Great. I think we should get you back as a careers advisor as well for the next podcast, Amelia.
I did used to do, but 10 things to consider before doing a PhD was one of the lectures I think I gave for university students. Just don't do it for the title.
Well, that was a great discussion. Thank you so much, Amelia.
Honestly, it's been a pleasure. Thank you for having me.
We hope you enjoyed the podcast. If you'd like to listen to other episodes, head over to the MBA website and go to Our Magazine, which is under Our Membership. And the magazine is just one of a number of great benefits of Marine Biological Association membership. There are categories for everyone, so have a look at the website and consider joining our community.
Thank you very much for listening. This has been the Marine Biologist podcast. If you've enjoyed this episode, then please check out our other episodes. Please subscribe to our podcast. Please rate it, share it with your friends and family, and let us know what you think. And we will look forward to welcoming you to the next episode soon. Take care.